recording.
Yeah. Hello. Yeah, let me share my screen.
Uh,
Can you see my slide deck?
Not yet.
Not yet. Okay. I share.
There it is.
Oh, okay, cool. Yeah. I think it's kind of because it's weird. I'm actually not in Chicago, not at home right now. So I'm in Raleigh at a co-working space, which the Riot Labs is letting me come because yesterday I was speaking at the Riot Dev Day. So it's a developer day yesterday. But so I'm still there. So at this co-working space, so I only have one laptop. So I need to actually look for my screen, but when I see my screen, then I can't see. Oh, actually, I can see all of you, but I'll have to shrink it up because I only have one screen right now. So, okay, so maybe I should start. So I have 45 minutes, am I correct, Mark?
Yes.
Okay, great. Okay, so I'm gonna start. So my topic about for today is empowering Java developers with generative AI, and then it's from RAG to responsible innovation. It's kind of a mouthful. I'm going to cover a lot of kind of aspects of generative AI. What does it mean for Java developers? I hope too it will be helpful for you, especially if you are uh, sort of like brand new. I'm sure you are all very experienced folks and in maybe less of Gen AI, but so that's the goal. It's a bit more introductory in terms of Gen AI. So, and feel free to interrupt me too if you find that something is confusing or if you need more information on that. But I do have to say that because of a short duration of the presentation, so I won't be actually doing much coding in here at all. And but I have a Twitch stream that I'm sharing. So I'm about to restart my Twitch stream. So that's where I will be doing more consistent, like weekly, maybe like bi-weekly live coding too. So okay, so that's what I'm gonna start now. This is the agenda. I will go over just a quick introduction of myself and then a brief background of GenAI. And also then I will touch on all of the key topic areas like prompt engineering, retrieval augmentation, vector store, similarity searches, and agents and workflows. So as you can see, just squeezing everything in. I hope to give like key points of each aspects and give you a good grasp on how you can start working with it. Plus, I'll share with you a bit of a, reminder too of the challenges of Gen AI as well. So, quick intro. My name is Mary Grigleski. I'm the Director of Emerging Technologies at Callibrity. Essentially, too, I joined a year ago or so, helping to build up the AI practice. But as such, AI too. Well, I should actually first say that AI isn't all new. But for some reason too, when ChatGPT came out, it often bring this whole AI and machine learning all to the foreground, and it as if it never happened before. But the fact is, there's been a lot of research going on, even within the past century too. So I'll take a look at it. We'll take a look at it at the next slide too. But and again, about myself, just pictures worth 1,000 words. So I'm just sharing with you in terms of all of the logos here. I'm also a Java champion. I'm actually very passionate being an advocate. I was at IBM before and then DataStax for about 6, 7 years. And I do a lot of presentations and outreach work as well, and now also running meetup groups. And I really am passionate about working with user community developers, especially, and now also with customers as well, or potential customers. So, but my really deep interest too, that sparked me off working with computing is really distributed systems. I think at the core of everything, it is distributed systems. And I find that the AI, what the hype is today, nobody touched on this aspect of distributed systems, which are so important. And especially too for Java developers, I feel we have a very good edge in terms of distributed systems. So we want to try to see how we can bring Java into this whole picture of AI. I mean, we're behind, I should say, right? Because Python has the upper edge. But I think there are lots of areas that we can step in and also contribute, right, to this whole ecosystem too. So that's me. Oops. I think I lost something. I'm sorry. Let me go back. Oh,
Scale.
sorry. Sorry about that. I think I clicked on something and then I lost it. Oh, here we go. All right, yeah.
There we go.
Sorry. Can you see? You can see now. Okay.
Yep.
All right. Sorry. I think when I click on one of the links. So sorry. Okay, so I'll go into brief background of GenAI first. First of all, I think we are all, like it or not, we are already consumers of AI. It's like the cake is there. Even if we don't want it, it is there. And we are already using, right, open AI, ChatGPT. Everybody seems to be all familiar with that, first of all. But then, of course, there are other models, other interfaces we can use. One of which I like to recommend is Perplexity, if you haven't used it yet. It uses a combination of LLMs plus also real-time searches too. So Perplexity, I find their answers a lot more accurate too because of that. And then, okay, so now I have it on the right side is the producer. So we are here for this meetup because this talk too is particularly targeted for people like ourselves. We're experienced engineers, developers, we're builders. We're going to be, some of you may be training models as well. We're the ones making the cake. So, and again, I mentioned too, AI came into being already about 100 years back, back in the early 20th century, around the World War time. And of course, Alan Turing, one of the, really true like computer pioneer too. In the 1950s, he has this book that says, Can Machines Think? And it sparks off a lot of, or has sparked off a lot of research, sort of like he was the pioneering person that gets into it. And as you can see, right, this timeline, I'm also sharing the link to. I find it very nice that I highlighted a lot of the key kind of inventions, right? The milestone within this whole century. And then we're now in the ChatGPT time that came out 2 years ago in 2022. But it's not, by no means it is going to be the thing that a lot of media is talking about, that it will take over our jobs. No, nowhere near, I should say. So, and I'll explain why in a little bit. But after all, too, about AI, it is all about automation, making our lives better. So here, too, I also wanted to quickly share, too, because there's also been a lot of confusion, or kind of like all of the terminologies that are flying around. So I want to lay them out in pictures. And the one on the left side is really the high level AI. Is all encompassing the intelligence and behavior pattern of humans or any other living entities. And then, of course, you get into machine learning, in which actually the computer is going to start learning based on the data we feed it. But also, too, is that it doesn't require any active, like, kind of participation of us, of human beings, to train it. We let the data to train, to train this robot too. But without and I also just wanted to point out, machine learning essentially has three broad categories. It's about supervised training, unsupervised training, and reinforcement learning. I won't get into all the details, but then with all of these kind of approaches to train, machines, machine learning, it's not enough, because what is really adding to all the magic that's happening is really going to the deepest layer, which is the neural networks or deep learning layer. So that layer deals with techniques that are mimicking how the human brain works, how our nervous system kind of communicate with one another. And then if you go to the right side to this picture, I feel that there's a need to also expand it a little bit, particularly with the Gen AI era that we're in. So as you can see, Gen AI is sort of like the intersection deep inside the deep learning kind of area, within even the neural network space. And there's large language models, which is heavily depending on natural language processing, NLP, because that's what is monumental too. I think about this ChatGPT kind of invention 2 years ago, because now for the first time, machines is able to understand human languages, and being able to respond to it. And just also remember too, what it is doing, it is the techniques to make predictions. So if you give it some prompts, it will actually, based on the prompts, it's going to make predictions based on what you prompted it. So that's what, technically speaking, that's what it is. And so it's relying on a lot of NLP, understanding human languages too, and even some of the nuances as well. So now I like to also explain too, I have this data too. Data is of absolute importance too. So without data, there wouldn't be any AI or machine learning at all. So data is of absolute importance. That's why there are lots of, kind of concern too. There's the AI safety the ethics, with AI responsibility, all of these things too. Okay, so I'll look really quick look into the Gen AI era. Really quickly to generative AI, what it is very disruptive field in AI. So it has the potential to change the way we create and consume contents, which we are already seeing. But the thing I wanted to point out is that Gen AI, what it is bringing in different than previously, the predictive AI, is that Gen AI as such, well, the name generative, it will generate code, generate things for us too. It has that generative perspective, but otherwise too, what it's actually was always doing is doing the transformation side. That's still happening as such. So this generative AI too, the one thing about it is it tends to be more on the creative side. It's about generating code, writing an article, or designing fashion, all of these things too. Whereas predictive, it is also making predictions too. But it tends to be strictly has a time limit to it. For example, we're making business or marketing weather forecasts, kind of forecasting with the time kind of limitations to it too. So that tends to be the case. This one I won't kind of step through all of it, but just a couple of like major milestone to during the, as things are leading to the Gen AI era. So 2003, about only 20 years ago, that was the feed-forward neural network from Google too. And then Apple brought AI and NLP assistant to the masses by its first iPhone with Siri too. Now the difference is that Siri also deals with audio and everything, but then it doesn't have what it is today too, with all of the generative kind of more the deep learning, the making all the predictions, all of these, the models too, that's missing in there. And in 2013 too, there's also from Google is the word-to-vec. And that's important technique because it basically is the techniques to make use of NLP. And it uses also neural networks to learn words, associations from a large set of texts. So that forms the basis of vector database. So I just wanted to point that out. And in 2017, there's this famous paper also coming from Google. It's called the Transformer. It's a simple network architecture. And the important tagline from there is attention is all you need. So those are kind of like the important kind of research paper that leads to where we're today. Oh, I'm so sorry. I think I'm... Again, click on the wrong thing. Okay, all right. And okay, so the next thing is wanting to quickly bring up too is the generative models. And as such, as you can see over here, I also kind of copy in a few kind of most popular models too. And, first and foremost, OpenAI, GPT 3.5, 4.0, and now there's 4.0, 4 mini and 01 mini. These has a reasoning kind of aspect to it. And one thing I like to point out is that we talk about AI, artificial intelligence, but there's been a lot more investment too that are, or not a lot more, but at least some of the big vendors are doing things on AGI, right? Artificial general intelligence, which actually kind of temper or kind of get into the reasoning aspect. And that's actually is going to be very difficult, even though we may have heard OpenAI come out and said, oh, they can reason things, but I think we're still far from truly having any kind of machines able to reason things, to really think ahead of things. And you can't even figure out emotions, all of these things that are so human too. But in any event, I just want to point out, right, 01 mini, and there's also 03 that quite recently that just came out. And then there are also different modalities of models as well. When it first came out was text and then transformed text to text, but then there's also stable diffusion that came out. That's the first successful image to text kind of diffusion model too. And then I want to point out there's a BERT in here. BERT is actually just a transformer. It's important enough because it's from Google. And so BERT, it only has a transformer model, but not the generative model. But it is still important too in this whole timeline of development of all these models. And then, of course, if you look around, there are others like Llamas from Meta, Grok, from X, and Claude has Anthropic, and Cohere, Qwen from Alibaba. Mistral is from the first European open source. It has the open source model as well as pay model. And Dolly came out after Stable Diffusion. It's all image diffusion, Midjourney, all of these things. DeepSeek, of course, everybody's heard of them. So all of these, and Codex is for coding purpose too. So, okay, so now let me also point out too, there are generative platforms or apps too. first and foremost, too, maybe some of you or a lot of you also may be working for companies that are already using cloud platforms. And then the big three, right? Amazon, Azure, Microsoft, and Google, they have their own cloud platforms that they actually also have added in like AI, like optimized apps into it. So for example, Amazon has SageMaker. You can do training. Everything is within the platform. Is make it easier to all of these things. And then Azure also has their Azure AI platform that also integrates very well within their Microsoft ecosystem. And then Google Cloud has Vertex, and also the Vertex, it's basically Gemini model, but Gemini also is a platform that uses their Vertex AI and that too. So all these two, they are great. You know, if you kind of have some kind of work that you need to be doing with AI that kind of doesn't require as much customization, I'd say, then those are probably good to start with. And also if you're already a cloud subscriber, that probably is the case. And then some of us, you know, we have customers that are already heavily using this platform. So that's also good too in that sense. However, a lot of GenAI kind of applications too, I'm sure, you know, there are specific needs that needs customization. So that's when you want to develop your own thing rather than relying on any kind of specific AI optimized platform from these cloud vendors too. And then there are also other examples of all of these apps in here too, like Gemini, for example. I was mentioning GitHub Copilot. It's also, you know, has its own basically helping you with coding assistance. And there are many other coding assistants, which is, I believe, as developers, we're probably first and foremost would be using coding assistance first, because that's what we do. We're producing code. We're relying on model to help us be faster too. So. Okay, so I wanted to quickly also point out the modality too. Again, I mentioned about there's text. There are essentially 6 main modality, right? There are text and image, code and audio and video and 3D. And then the thing is too, even like a year ago, we still were hearing a lot of these companies, vendors are doing models that can have kind of intermodality, kind of support a multimodality. Amazingly, too, I think things change so fast as such. You know, Gemini is actually a pretty good multimodal that supports multimodal kind of a model in there. OpenAI, again, I mentioned about O1 of the GPT-4, for example, are already like supporting multimodal kind of thing. But there are specific models, such as like OpenAI has also Sora, that's for video, or audio, it has Whisper. Image, I mentioned about the Midjourney, Dolly, all of these things too. Code has Codex, which is what GitHub Copilot uses too. And then there are 3D models as well. Okay, so this I probably will just skip quickly, but wanting to kind of talk about, actually, just want to go to ChatGPT, all these things. I guess I won't kind of step in too much, but just I already talked about natural language processing, large language models, but just a word about large language models. And that's what, as developers, we interact with the most, because that's kind of like the runtime. I kind of like to think of LLMs are like a runtime for AI type of applications. And then it's much like JVM is what's kind of operate on the coding level. So in some sense, right, not exactly, but LLMs is what help generative AI to happen too. So as such too, I wanted to point out though, one thing is about LLMs is that they are very expensive, right? And I mean, it's easy to say, okay, we can use LLM to search for things, but guess what? Nobody kind of likes to bring it up that uses a lot of GPUs and all of these things. They're just, in general, is expensive. But it is definitely powerful, don't get me wrong. And but wanting to kind of say that it deals with code generation, you know, it deals with transformer. That's what it is. The models too will do transformer and also has the generative capability to it too. Okay, so here too, let's kind of take a little quick look again. This one's from Google Cloud, and essentially too, that describes AI, machine learning, deep learning, how they kind of relate to one another, all of the layers too. So I thought this is a good diagram, and I think I might have also a link to it if you are interested to kind of understand LLM from a visual kind of perspective. Look, another thing I want to point out is that as I'm also doing more of this, there are also variations. There's a SLM, which is small language models, and by no means they are like, you know, really like incapable, but it's just what it means is that it's just more catered for maybe certain types of domain So then the size of these small language models are really purpose-built, for serving certain kind of domain kind of needs too. So they would be, because of their size, so they're easier to load and all of these things. So performance-wise, they should be faster too, but also accuracy too. It all depends, right? If you want to have certain things that are, serving specific domain, then you may want to consider SLM for certain types of apps too. And then there are also LCM, like language conception model, all of these like variations as well. So I just kind of wanted to point out that to you as too. So about LLMs, I wanted to kind of bring it up. It's actually very limited too, as much as it seems like it's wow, powerful. All the vendors are investing, or the big vendors, it used to be at least, right? All they talk about LLMs and training models. I mean, as much as it is powerful, but it's actually, if you think about deeply, it's not, nothing is perfect. So there's no memory in itself, and also it's basically too, it uses a non-deterministic kind of techniques, right? In kind of predicting tokens, all of these things. It's essentially fuzzy logic. So the results are probabilistic. So if you ask the same question to an LLM like 100 times, it will give you back 100 different answers, or close to that, right? It's not the same every time. It's because it's not like us as software developers. We're more like wanting to have things more precise, precision, all of these things. It doesn't have that kind of a knowledge because it is making predictions based on the tokens. And it can vary, kind of between different asks too. And also too, basically, it's also opaque, meaning that you cannot add any attributions to its answers too. That's another thing. And not to mention is very costly. It uses a lot of GPUs, even though right now the chip makers are making it cheaper, but it is still pretty expensive. Even like 2 months ago, I know I was just attending a panel with somebody from Google. They were just talking about how you can be using a nickel to ask the same question, using regular Google search. But the thing is, using an LLM, it at that time was saying that could cost $4, per ask. So all these things, I think in general, we don't think so much about it, but that's the thing. There's just hidden costs to which to that too. And not only that, because of its not having memory, so all of the things when you use it, it's like a one-shot deal, right? And that's the thing too. If we know exactly what we want, some smaller problem set, craft up your prompts really good and ask the question, it will come back beautifully. It can be designing a dress, writing an essay, doing a blog post, whatever it is, right? Asking some question, it comes back beautiful. However, if you think about us, especially if we're working on bigger types of applications that deals with end-to-end, what about an order entry system? What about a flight reservation, fraud detection, all of these things? We actually need to have systems that are scalable, that in certain circumstances too, needs to be able to handle concurrency, parallelism, all of these processing, the very difficult problems that distributed computing is trying to solve, that for humans are not easily achievable, right? And can we expect the LLM to do it? No. Or even like these days we talk about agent, right? I have yet to see an agent being able to figure out all of these things, the difficulties in solving distributed systems problem. But I think also too, the way the world is looking at it, maybe all the commercial, they are just coming out and saying, oh, it's going to take over the world. There are no needs for software engineers. I think they're overlooking a very important area, which is distributed computing. I don't think it's there yet, maybe at some point, but not right now. So that's my thing. So it points back to LLM too. Complex tasks and workflows, I just don't think it is ready yet. But the thing is, it will require human in the loop, and that's what it is, right? You can be using agents doing all these things, have human to do all these things, sure, certainly, but to do it all completely autonomously, that's actually still a ways to go. So there's no need, I think what I'm trying to say is there's no need to worry that our jobs will go away. I think it will come back, and in fact, I saw people posting, right, on social posts, they're asking LLM to generate some code or migrate some code of a complex system, let's say even just order entry. It comes back, it generates the code, but then it looks beautiful, looks like it can compile, but nothing works. Nothing is working correctly. So that already explains, right? So, and also there are also another post that says, yeah, that you can actually, you will actually need software engineers to be there to fix all the problems that these LLMs have generated, their wrong code and like that too. So anyway, so that's my kind of comment about that. So again, LLMs are powerful, but it's nowhere near when we're talking about serious computing, about distributed computing. Okay, so now how can I work with LLMs? So I just want to point out, right, if you're Python, then LangChain seems to be always the big thing, the SDK you can use. And there's also this other one quite popular called Llama Index. And they are more kind of suitable for dealing with data retrieval, indexing, all of these things too. And that seems to be working pretty good and also integrates very well with a lot of vector database. And then from Microsoft, there's also an open source SDK called Semantic Kernel that actually has different language platforms integration. Like first and foremost, of course, they have their C#, but also works with Java and Python and TypeScript, all of these things as well, and other language too. And then Gemini has Gemini API as well. And then Hugging Face, I wanted to point out is that that's kind of like a repository for developers to use it. It's sort of like GitHub. We use GitHub to store all of our repository versioning. But for Hugging Face, it's also another community on that level for helping to share like AI models. People want to take whatever model is this and do refinement, for example, refining models, and then they publish their own kind of variations of the model. They would upload it for sharing. Also data sets and all of these other things. And also they have a workspace, all these things too. So Hugging Face may be also a good place. If you're not already using it, you may be able to find it useful for yourself as well. And then for Java-based API frameworks, I'm kind of pleased to start to see more, options too. So first and foremost will be LangChain 4J. It's not the same as LangChain, but it uses the concepts, and then it's basically the Java version, and it's getting better and better. And then there's also from Red Hat, the open source project Quarkus. And earlier too, I was talking to this gentleman here. Quarkus is then highly optimized for cloud native types of deployment. And it kind of trims down it doesn't use jar file anymore or all the archive files. So it's basically trimmed down your executable, essentially. And it also has a nice integration with LangChain 4J. And also, too, I have some example, too, also within the slide deck if you want to start taking a look at it, because myself and with another Red Hat person, we did a talk, a workshop in which we also showcase a Quarkus LangChain 4J integration, too. And then there's also Semantic Kernel has a Java SDK from Microsoft. And of course, Spring AI version 1.0 just came out as well. But I'd say Spring AI is still not quite, up to par with all of the LangChain or that, they're like in terms of AI kinds of usages. But I'd say, Spring is pretty good too already, get caught up quite fast, but still got some ways to get caught up truly. But at least the 1.0 is there now. And then there's also an open source project called JLlama. It's by Jake, this person, Jake, and he actually, I worked with him previously at DataStax too. He's the chief architect and now part of IBM now, DataStax. So he has this port of like the Llama, and he supports only a few models in there too. And it works reasonably well too. And that's JLlama. And then there's also a JVector library also from Jonathan Ellis. He's the Apache Cassandra kind of whiz person, right? He started DataStax. So he has this vector library that's optimized for, say, using a Project Panama from Java to work with, to enhance the vector API too. So that really helps with, if you're serious about developing infrastructural thing, JVector probably would be very helpful for vector linear algebra type of algebraic kind of methods too. And then there's also Llama 2, which actually a direct port from Llama C. So these are some of the Java framework. And just a quick example too, how would you work with LangChain 4J? So over here too, I'm not actually doing anything, right, other than using the model to generate. I'm not actually asking question, but over here you can see all you need to do is just do an OpenAI chat model. And by the way, if you're using OpenAI or any kind of models, they tend to require you to get an OpenAI API key too, so you can get that for free. But then, of course, if you start to use their model, if it's OpenAI, then it's not all free too, as you know. But however, if you want to use any models locally, you can actually use Ollama, for example. That's one of them. And there's also a LM Studio that has a GUI interface to it too. And basically, too, with Ollama too, it depends on what model you use. And if you use Spring, but Spring AI does require the OpenAI key, even though, let's say I'm using Ollama and working with a free model, DeepSeek, and like that, but Spring AI does require the OpenAI API key, just so you know. But like I said, if you just get like a $5 something to start with, it actually can last for quite a bit too, as long as you don't use any of the expensive and most up-to-date model. But as you can see over here, you basically have your model and associate it with the key, and then you can then do a model generate. In this particular case, it's basically a hello world, and you get the answer, and that's what it is. It's just generate, and it's not actually you kind of using the LLM for any particular case. It's really strictly an open world app in here. So I realize I have to go a little faster. So getting into prompt engineering. So what is prompt engineering? So basically, it's asking an LLM to perform a task in a way that will increase the likelihood of receiving a correct response. And how do you write effective prompts? So there are a couple of books too that we're sharing in here too, so you can kind of take a look in here. And again, I'm sharing this slide deck towards the end, so you can always get the slide deck and don't worry about missing it. Okay, so first of all, I think the interesting thing about prompt engineering is that it's really about communication. It's less about actually writing code. And in fact, a lot of the prompt engineering jobs are people these days, they actually do not even write code, and they just need to know how do you communicate with your machine to kind of get the answers that you want. So it really requires the language skills in here and the art of communication. So first and foremost, so you want to write clear and specific instructions. And then even when you're writing it, you want to make sure you use proper delimiters and to separate out different parts of the input. So you really have to pay attention to language. So if you have knowledge and linguistic, then you can probably know how to interact with your large language models effectively in that sense. And so some knowledge of that is very helpful too. And basically, you want to provide details to perform the task, and also ask it what types of output you want to see. Is it like, can it be JSON? Are you expecting HTML or just strings and all these things? You can also specify that as well. And you want to also include any conditions that needs to be verified before performing the task. And then also you can give examples too, like, so for example, like one-shot or few-shot prompting as well. So this one is just some use case. I probably won't kind of step through because I also have other topics I want to go through, but you can kind of take a look in it too. So basically, this is an example prompt. You can say you're a helpful meal planner, and your job is to suggest meals based on the recipes and user input. And if the user input is a question or request not related to generating a list of meals, and then reply, sorry, I can't answer. I can only provide meal suggestions, and then give it the recipe, for example. And then there are certain template that you can build it up to like that. So as you can see, there are also updated prompt in this particular case. I won't read it out now. There are also, interestingly, you can also, I'm sure you've used it too, like in prompts too, or you can even tell the LLM to say, come back with a response and answer it as though you are like a young child, 10-year-old or something. So those kind of things, the LLM is supposed to be able to figure it out to what kind of audiences, all of these like little nuances, you can also guide the LLM to answer for you too. Okay, so these are just few shots from, and just want to get through. And basically, too, the second point is that besides writing out your request, your prompts carefully, you want to ask the model to think through the response too. So there are like, in LangChain, it uses this chain of thought kind of prompting. That's kind of the concepts we're talking about. So basically, in complex reasoning, it's not just, we require multiple steps, right, to for the model to kind of think through. So some tasks, is again not just one step, there are multiple steps. So you want to make sure you use prompting that's also take into account that it could involve like multiple steps in solving the problem. So you also essentially include a chain or series of steps the LLM must complete before providing its answer to. So here too, this one is an example of a chain of thought prompt, right? So over here, as you can see, like, a simple example is kind of interesting. It says, when I was 4 years old, my partner was 3 times my age, and then now I'm 20 years old. So how old is my brother? And return the answer directly. And it comes back, the ChatGPT came back and says 32, but of course that's wrong. So then you can prompt it again and set that, we submit this question, and then also basically tell the LLM to say, please think about it step by step. Yeah. So now then you guide the LLM, then the LLM is going to break out your particular prompt. And first it says, when you were 4 years old, your partner was 3 times your age, and then they would be 12 years old at that time. So then the next thing was saying that, okay, now I actually need to figure out the age difference between you and your partner. So that's 8 years. So now if you're 20 years old, then your partner's age is 28. So that's the kind of thing is kind of interesting. So there are also lots of kind of information like this, examples too, from this particular book down below if you want to kind of take a look. Okay, so now I'm going to move on to the next section, which is about retrieval augmented generation, RAG. It's being talked about a lot too. And in fact, some of us here in Callibrity already have done an example implementation too. So just wanted to kind of quickly summarize. It's basically stands for retrieval augmented generation, and it integrates 2 components of these models. One is the retrieval model, the other is the generative too. So the idea, why is it so? Because you want to produce text that's not only conceptually accurate, but also information rich. So let's take a look then. This particular diagram explains this in kind of very high level. I'm already hiding a lot of things in here, but you can also take a look. The source, I took it from Vectorize, this company that specializes in building RAGs and agentic RAG these days. So as you can see, step 1, right, we can have user submits a prompt to the RAG application. So I send the RAG, or send the prompt. So the RAG application receives it, and what it does, first of all, it will go and retrieves relevant context from the vector store. Bear in mind that vector database is sort of like augmenting the storage, right, of some data that for the LLM, which isn't already been used for training the LLM. So the RAG can go over to the vector database, get some initial information, and then from there, it will enhance your prompt too. Basically also stuff in and say that, okay, now, then before you submit to the LLM, the RAG will then take the prompt, takes the answer from the semantic search and comes back and enhance that original prompt and adding this relevant context to the LLM. And then in that case, you send it to the LLM. So now LLM has more things to work against. And then now it's supposed to come back with a better answers for you too. So it comes back in the response. And so in this particular case, then the generative model will take over, because the generative is there to further enhance, the context of the answers, and also making it very rich to kind of enhance it and doing more things. And of course, I'm hiding a lot of details in here. In reality too, as such, right, we can think of this kind of applications very applicable for, let's say, enterprise companies. I'm in a finance department, and they're handling a lot of different accounts from different customers. Some are, accounts payable, some are accounts receivable, different kinds of invoices, all of these things, and they come in the form of different PDFs file, or even like a Word doc, or some kind of any kind of format, JSON or unstructured kind of data as well. So, or images as well. So there are also techniques that you can actually screen, your images of an invoice and kind of extract out all the information and save it accordingly too. So all of these things, and not to also mention by itself, it's also complex to try to analyze all of these different fields. Let's say we're doing government quotes and they have 180 pages. For example, one of us, Eric, who's the service delivery director, has to come across that. And we're also trying to kind of use this kind of approach. How can we do an automated RAG thing to handle a bunch of PDFs that are going to be larger. By the time you combine all of it and send it over to the LLM, it's going to be over the limit, right? Because LLMs have limit too. You can't, just send all your data over. It's just overloading. And in fact, we try it out with Gemini, and Gemini came back and spit out garbage towards the end. It was kind of interesting. Anyway, so what it is that within RAG itself, there are lots of techniques. For example, like chunking is another big thing that I can actually do another talk, just talk about chunking. How do you split up your data? How do you deal with the data in different formats, all of these things? So that too, I'm already hiding. But just bear in mind, there are also that aspects of the RAG. We need to deal with all of the data. And then, of course, there's vector database, which I'll touch upon shortly after this. And then also, too, like the LLM is going to be processing all of these things and then comes back, and then the generative model will take over and generate the results and package it up, beautifully send back to the end user. So that's the idea. And again, I have this link in here where you can take a look deeper into RAG, too, from vectorize.io's website. Okay, so now just a quick summary. So retrieval model essentially too will act as a specialized librarian, pull in relevant information from some external data source, from a database or a corpus of documents, or could be even from a Kafka topic. And so in other words, you can do real-time type of data that stream in and you pick it up as it goes kind of thing, or message queue or socket, and I'm talking about TCP socket or some kind of thing that you're picking up data from. So from there, then we go through that diagram we just looked at, and then now it will get fed to the generative model, the results from the LLM. So now the generative model, it's kind of acts as a creative writer. It will take the retrieved information and kind of form it into coherent and contextually relevant text too. And so it's basically what it is in here is that it has the capability to create text that is grammatically correct, semantically meaningful, and aligned with the initial query or prompt. So that's why too we are kind of in awe sometimes when we say, oh, we need to, let's say, even just write some kind of a proposal and have the generative, the LLM do it for you. It comes back kind of a surprise us, because it's doing a lot of this generative side is doing a lot of things to make it really sound really good too in that case. So both the RAG, the models of retrieval, and the generative models work in tandem to basically give you the final piece of the puzzle, essentially, and give you the textual output that we interact with. Okay, so that's RAG, and in 5 minutes. And now I get into vector database and similarity search. So that's another aspect too. So what is vector database? It's a purpose-built database that serves up vector data type for complex machine learning purposes. And so how it can do it is basically relies on vector embeddings. So vector embeddings are essentially numerical representations of the data that are stored in vector database. And you may be asking, like, why do we need it? But it's true, you don't have to have it. But then vector database is essentially, if you are a math person, then you are familiar with matrix representations of data, right? Essentially. So we're now looking at machine learning data that's basically, not just looking at things one-dimensional. It's not just, let's say, I'm storing a cat, The cat can be categorized into different areas too. Can be animals, can be, feline, can be like, some kind of object that's a living being with 4 legs or something like that. All of these, they are being categorized. So that's what the dimensions that we're talking about. And if you store them, let's say with traditional relational database or even object database, that will mean you need to have many fields, all of these things. And then somehow in relational database, you will have to build up all the relationship. And it will work, not to say it doesn't work, but it's not like kind of ideal for this type of multi-dimensional data type. So that's when vector database comes in, because now we're using a matrix type of way of handling all of the multi-dimensional aspects of data, which is perfect. And you can actually have many dimensions. Well, of course, there's a limit too. But OpenAI, I believe right now is it 16,000 or something, right? Dimensions too. So anyway, there's the limit. So that's what I'm trying to say. So vector database essentially is optimized to store that type of data. And then you can then operate on the data using linear algebra. Now, if you're a math person, take out your linear algebra. And that's what I did when I first learned about vector database 2 years ago. And we were kind of being told, you must work on it. I said, no problem. And I dug up my book full of dust that I never actually used any of my math, even though I have a math background. But finally get to use it. So exciting. But anyway, so that's what it is. So basically, all of the data too gets translated into numerical representations, and these are vector embeddings. And they are, if you look into a database, they are essentially an array of multi-dimensional floating point numbers in there. So it gets translated. It has to base on some specifications too. So in OpenAI, they also have a couple of specifications that helps you with embedding kind of translations, but there are also other specifications as well. So if you're working with vector database, make sure you use the same spec for both storing and extracting data, querying as well. So, and essentially too, vector database too, when you go and actually do selection is basically using these techniques called approximate nearest neighbor. So all these two are essentially dealing with, again, with vector multi-matrix map is basically either using dot matrix product or Euclidean or using cosine similarities too. So those are kind of like the three main types of techniques, right? That measure the angle between different data or like the distance and all of these things. So again, I won't get into all the details. If you're a math person, if you are kind of curious, feel free to kind of look into it. So here, let me kind of quickly explain a little bit the mechanism. What is a vector embedding? So basically, I'm using a very basic example, which doesn't exist in reality in complex world, but it's for illustration purpose. I'm using a 2 dimensions normalized vectors. So in this case, this V1 is my search. So let's say I'm searching for something and I pass it a search string, and that's represented in this particular case as V1. And then there are many data too, let's say. But the thing is too, is that for illustration purposes, right, the embedding model will translate them, and that's how it's kind of placed in a two-dimensional space. And I'll find that there's a V1 I'm looking for, and then what will get returned to me will be V2 in this simple case, rather than V3. And while you can too, right? The thing is, if you're writing SQL code, you can also tell it, well, what's the approximation? How close do I want the answers to come back to me? It can be like, let's say 5% of deviation or something, or up to like 20% too. So if you kind of say that I want, I want to accuracies to be more relaxed, and you're going to get back a lot more answers. But if you want it more tighter, I only want 1%, then you'll probably be getting very few answers back. So that's the kind of key too. So as you can see, that's what it is. Now, kind of take a look at a more realistic example. I can be like searching for a cat, and then the dog is actually placed over here while a house is down there. And in this particular case, because the dog is also an animal, so naturally too, it would be closer to a cat, in that sense too. So the vector essentially captures the essence of the word or block of text within its context. So again, this is a simplified way of explaining the vector database and why it is helpful to use for machine learning types of storage and purposes too. Okay, so in reality, notice that we are dealing with many dimensions of data. So basically, in a vector search, it's basically we'll be using different layers in this case. So I won't get into all the details, but I just thought I'd share it with you. And also, and one thing I wanted to talk about, there's also built-in algorithms too. If you're really serious about it too, they're using the nearest neighbors embeddings, and there are also HNSW too. There are also other kinds of algorithms being used, and that's what HNSW is used to be used by Elasticsearch too. And just FYI, and then JVector, Cassandra, for example, I used to work for DataStax, so we're using approximate nearest neighbor too, and then also augmented using the JVector kind of. So that's why Cassandra, is being a NoSQL database, is actually super fast in doing vector search too. And then I just wanted to also share a couple of examples of vector database. These are open source. pgvector, for example, if you're a Postgres person, you may find it easier to use, and it's easy as just install the plugin pgvector into your Postgres and you're all good to go, or using a cloud provider like Supabase, for example. It has some free tier usage. And then there's also Milvus or Chroma. Fast is from Meta, and Quadrant, by the way, too. I've always heard that Quadrant is super fast, and it's written, I believe, in Go, and it's super fast too. Go or Rust, I can't remember, but one of the two. But they also has open source to it. And also Weaviate too. Also Weaviate also has some Java interface to it too, from what my understanding is. So. Okay, so these are usages for vector embeddings. Other than using for vector search, it's good too for using clustering, kind of similarity kind of purposes and recommendations, like order recommendations or anomaly detection, diversity measurement, and classification as well. Okay, so I kind of already mentioned about traditional database. You can be still using relational database to handle this, but the performance probably will be very high, because how do you handle complex data that is, you have to store many dimensions of it too. So like that. So just wanted to kind of point out too. Okay, this one is just a diagram just explaining how it's kind of relate in relationship to one another, LLM data, the responses, the embedding services, all of these things. So. Okay, so agents and workflows. So before we end too, I want to bring up agents and workflows. And basically, it used to be, agents are not new thing, just like anything in software. A lot of things get recycled. So agents, right? The concept of such is basically we want agents to be, to act on our behalf. And of course, too, I wanted to also point out, as Java developers, I think these are like no like big difficulty, basically. Because to me, I think agents are similar to what we're now more used to is the microservices, though not exactly the same. But the concept, as I'm also thinking too, is that agents are, we want it to be first, autonomous. The difference also with agents is ability to adapt to. So meaning that, circumstances change, or I'm actually, agent will be a tool. So then the thing is too, then my tool is going to interact with the LLM, which actually that's the VM, right? The virtual machine for my AI stuff. So the agent doesn't do the work, but I'm interacting with an LLM and let the LLM do the difficult heavy lifting in there. That's the idea. But the agents is of absolute importance in here, because it will act on behalf of me, all of these things too. And then essentially too, you hear about agentic. So agentic is basically, it refers to someone or something capable of achieving outcomes independently. And it's basically having agency, all of these things. So those are agents. And GenAI agents too, within the software context, these are software entities that can help to orchestrate complex workflows and also coordinate the activities of multiple agents as well that can process logic and evaluate answers too. So now it gets into multi-agentic systems too. I know I kind of jump right into here. So again, I feel that, simple agent are not, and I don't mean to say simple. Everything is complex these days. But let's say I have some task that I want to do in terms of generate some code. So I give it some prompt, and it will go and generate the code. And it fine, wow, works perfectly. But again, we live in a very complex world, and we're not just living, every day like, okay, just do this, do that, like that. But we're dealing with end-to-end systems, dealing with order entry systems that are going to have to first, look up the catalog of their inventories. It has to interact with inventory systems, and then you want to actually purchase something, then you go through purchasing, and then you also have to go through payment systems, and then from payment you go to supplier, not supplier, but the delivery side, all of these things. Again, I'm also simplifying too, but you get the point. So that's where the multi-agentic systems will come into play, is basically you want to have each agent is handling some subsystem, and they work autonomously together. And ideally, not only that, they need to be helping each other out. I think that will be another like a, kind of a big kind of milestone in computing history, if you can actually have agents being able to take the initiative to ask another agent for help. But I think that's kind of like the idea too. And it's quite fascinating in my opinion, right? So you can be using different agents to specialize in different tasks, and then you can have emergent intelligence from agent interactions too. And then you actually will be adapting as you go along. You're also learning you keep training your models to as you are doing things. So I think that's what truly a true multi-agentic system should be. I don't think we're there yet. And in fact, I spoke at a Michigan Tech Conf, and there was this speaker from what is it, EY, Ernest Young, right? He was an executive, and he made comments about he thinks a true agent system that can do that kind of stuff is going to take at least 100 years. So I think let's see, maybe not in our lifetime, but we're working towards that. Is what it is. But that's what it is, multi-agentic systems. So let's get back to earth a little bit. So we're talking about some fundamental building blocks here. In LangChain4j, there's this essentially a proxy object called AI services too. It's basically not the same as chain of thoughts in LangChain, but it's kind of using a declarative interface to the desired API underneath, and via an object proxy. That's the AI services. So that I just wanted to quickly bring this up. And also too, before I forget to, it's basically MCP. I think some of you may be already familiar or working with, however it is, reading up MCP, Model Context Protocol. It comes from Anthropic. It's a protocol that basically open protocol, and it standardizes how applications provide context to the LLM. So basically, MCP will let you build agents and complex workflows on top of LLMs. Now, think of it like that. My agent, my agent will have to know what kind of tools I can use, what kind of models needs to be connected with to do the work for me. All of the resources, all of these infrastructural type of information, I'm going to have to provide to it when I'm working, with different LLMs, let's say, right, the context. But what if we have like a standardized protocol? So then it makes it easier for you to work with different types of services in a standardized way. So then let's say if I want to switch, from LLM, I'm using OpenAI, the next day I will actually want to use Claude or use something else. My code, using this protocol, probably don't need to change as much. It's just more like configurational changes, then I can change some of these moving parts to it easily. But that's the idea of the MCP, right? Just like any kind of protocol. And it's basically built ideal for doing infrastructural, again, a bit lower level stuff too. Now, in come another exciting protocol. Well, I should say, like, it's not that exciting, I should say. But Google, at Google I/O maybe 2-3 weeks ago, they announced a new protocol called Agent-to-Agent Protocol, A2A. So it's basically, interestingly, when I first saw it, I said, gee, that's yet another protocol. But the thing is, it's funny too, is that when I went to their website, they talk about they are complementary to MCP. So I also provided a link in here and also copy over. It's interesting. They said TLDR, summary. Basically, agentic applications need both A2A and MCP. And it's basically, even from what they're saying, is that MCP is more for building the tooling, a bit more infrastructure side, and A2A is more for agents too. So that's what it is. So you can check them out too. Actually, I have another diagram too. If you don't mind, actually, I should have done a better job. I have just too many things in here, but let me. I have another diagram yesterday. Oh, not this. I've like too many. Sorry. I just want to quickly show. I just thought it might be useful too. Yesterday was not Discover. Oh no. You know what I'll do? I will actually have to share. Sorry about that. I hope I still have time, but quickly wanting to share another one yesterday. Okay, I was at the riot thing. And I forgot to copy over this guy. Let me do this. Okay. Now let me go back to Sinjak. Okay, let me go back to here. Sorry, I'm kind of doing life thing copying because I didn't do a good job in here. Okay. Here too. Oops. That's weird. Doesn't let me copy. Okay, well, you know what I'll do? I will that's a kind of bummer. Let me kind of share. And now I actually can get to. Okay, sorry. Let me really quickly share this. I don't know why I cannot copy it, and I'm so sorry. Let me share this and this. Okay. Okay, I just want to quickly share this one too. It's basically a diagram that shows you the A2A protocol. So basically, that's for agent to agent type of communication. Like I was talking about when one agent needs to reach out to another agent for kind of more higher level, abstract level of communication. You could do that. Whereas then MCP, as you can see over here below, is kind of really interacting more with the APIs, the enterprise applications, all of those things too. I just thought it might be helpful to kind of show that to you in this case, how kind of it looks like too. So that's what it is. Okay. All right. So now I have to kind of go back to the other thing. And again, I apologize because where is it? Okay, here. Okay. And let me slideshow again. And am I sharing? I don't think I'm sharing that yet. Let me go back to sharing. When I'm having too many things, sometimes that's what happens. And I cannot find, oh, here, sorry. Share, okay. Okay, now come back to here. So now I won't get into all of these. I have another talk that I talk about event-driven architecture and multi-agent too for GenAI, and I'm also working on an example too. So, but anyway, let me kind of quickly show you too this particular case, an agent type of scenario. This one is from Microsoft, the AutoGen. They have an example that particular AutoGen is actually pretty good in terms of building chatbots and also interject in like human interactions as well. So they have this on a paper at archive.org. So I'm also sharing it in here too. So you can take a look into here, multi-agent conversations too. Now, there's also like this thing called multi-agentic design patterns. And again, this isn't my talk about agents, so I won't get into all the details, but I kind of supply it here. If you're interested, follow me and I'll talk more too. Okay, and then there are examples of a few multi-agentic libraries. Again, Microsoft has AutoGen, and then there's also another quite popular rising kind of popularity agent system called CrewAI 2, and they're Python primarily. That's their drawback, doesn't have Java yet. And then there's also one called LangGraph, and it's basically based on graph theory too. It's a little bit harder to do, but then it makes extensive use of graph theory too, and it's from LangChain. And then there's also Agent Engine too. This one is very interesting. It's from StreamNative. They are the ones that actually kind of custodian for Apache Pulsar, which is a streaming platform much like Kafka. So they came up with an Agent Engine too. So just announced. So I'll be interested to also find out too. And there are more to come too. So okay, so let me kind of, before I end, let me kind of point out, since I'm running out of time, and just to remind ourselves, right, when we're working with these Gen AI thing, there's still the problems with hallucinations in the models, the LLM side, and there are also ethical concerns, potential misuse too, and no one is there to actually oversee all of these things as well. And how about real-time up-to-date data? Now there's RAG pattern that can help now, but then to implement it, it's still, I'm not seeing a lot of examples. I'm planning, again, working on this event streaming thing, then I wish to be able to show you too at some point. So very soon in the near future. And then there's also scalability and security concerns. Now, I didn't even talk about security. I've often thought that, well, we have all these agents and then we want agents to ask questions, but how do you know agent is it like permitted? Is it authorized to ask the kind of questions, right? All of this security thing, that's what I think is inhibiting the growth, the real production work towards it, because companies like banks and financial institutions are not going to be trusting this thing yet. It says too many unanswered questions. And there are also sustainability issues, as I mentioned earlier. And also, too, with prompt, there's the danger of prompt injection, much like SQL injection too. So from a programming point of view. So thank you very much. And just want to share the resources. This is the slide deck and also the QR code. And I will be sharing this with Mark too, if you miss it. And this slide deck has all the information. But just wanted to point out, I have a couple of links in here to some open source ranking information. And also I have my stream too, my Twitch stream, as I mentioned to you. I'm also multi-streaming to YouTube. So if you're interested, I'm going to start doing some actually live coding stuff too. And also, if you want to join me, you are welcome to join as well. I can just send you a link and you can join my stream and we can talk too. And also too, I did a workshop, AI ML workshops. I was hoping to show, but I'm running out of time. But a couple of examples in there too, if you want to take a look at this AI ML workshops in here. And then also Hugging Face as a dataset viewer, I thought they would be useful to know. And with that, I want to thank you very much. And this is how you can get a hold of me. And of course, I'm at Callibrity, so you can always find Mark and you can find me too. So thank you very much. And also join some of my CJUG and also AI Collective meetups as well. So thank you very much.
All right. Thank you, Mary. I appreciate it. Are there any questions for Mary?
Just the first link that you provided on the slides.
Oh, the slides. Okay, sure. Oops, let me kind of go back. Yeah, here, this one, right?
That was it. Yeah.
Yeah, okay. Yeah, so you can then get hold of all the information. So I hope it's been helpful. It's just more like an introductory type of talk, but I know I cover a lot of details. Yeah, but feel free to reach out to me anytime too. So
Yeah. And then the last one before
the last one. Oh, yeah.
One before the last slide. That one. Nope, the one previous.
There
you go. That's
this
it.
one. Yeah, Hugging Face as a dataset viewer. So I thought it's very useful. Yeah, yeah.
It is. Okay,
Yeah.
thank you.
Thank you. Yeah, thank you for joining my talk. Thank you. Yeah.
Oh, I love them.
Oh, thank you. Thank you.
I wish I know I may have missed some, but today I was able to make it.
Oh, thank you. I appreciate. Yeah. Yeah. Yeah, thank you. Thank you so much. Yeah. And if you have questions, feel free. Join my Discord server or ping me on X or LinkedIn.
I definitely will.
I'm always there. Yeah. Thank you. Yeah, great.
Very informative. Thank you.
Oh, thank you. Thanks. Thank you.